An intramolecular bond is a bond that holds the atoms in the molecule together. All intramolecular bonds depend on valence electrons. If an atom doesn't have enough valence electrons, then another atom will come share with it. Electronegativity is the tendency of an atom to draw electrons in a bond towards itself. It increases as you go across the period, and it decreases as you go down the group. So fluorine is the most electronegative atom. The first type of intramolecular bond is an ionic bond. This is a bond between two ions which are formed from the transfer of electrons from one to another. The next type of bond is a covalent bond. This bond is formed by the sharing of electrons between two atoms. This makes the molecule a poor conductor. Now we have nonpolar covalent bonds and polar covalent bonds. A nonpolar covalent bond is a covalent bond which the electrons are shared equally. A polar covalent bond is a covalent bond in which the electrons are shared unequally. Just because a molecule contains polar covalent bonds doesn't mean it's a polar molecule. That is determined by the dipole moment. The dipole moment depends on two things: the degree of overall separation between the atoms in the bond and the distance between the positive and negative poles. Next we have metallic bonds. Metallic bonds usually form within pure metals or metal alloy. The metallic bonds usually have a large, what is called sea of electrons around them because the electrons are delocalized. All these bonds determine boiling points, melting points, and a whole bunch of other stuff that's important to chemistry.
Intermolecular forces are the forces of attraction that hold molecules together. There are four types of intermolecular forces: London dispersion forces, dipole-dipole forces, hydrogen bonds, and ion dipole forces. London dispersion forces are the weakest intermolecular forces. They are present between all molecules. They are stronger between molecules that are easily polarized and weaker between molecules that are not easily polarized. You can estimate the strength of a London dispersion force based on the size and shape of the molecules. Dipole-dipole forces occur between the positive end of one molecule and the negative end of another. They exist in addition to London dispersion forces, not in place of them. They are stronger than London dispersion forces, but they are not the strongest intermolecular force. The strength can be determined by the electronegativity of the molecules. Hydrogen bonds are one of the strongest intermolecular forces. They exist when the hydrogen atom of one molecule bonds with the nitrogen, oxygen, or fluorine atom of another molecule. An example of this is water. A hydrogen atom from one water molecule is attracted to the oxygen atom of another molecule, forming a hydrogen bond. This is not to be mistaken with the intermolecular covalent bond that keeps the hydrogen and the oxygen atoms of one water molecule bonded. Finally, we have ion dipole forces. These are the strongest intermolecular forces. They are stronger than dipole-dipole and hydrogen bonds. They exist when an ion and a polar molecule are interacting. Intermolecular forces are all weak compared to intramolecular bonds. As the strength of the bonds increase, the boiling point increases as well. This means that the boiling point can be used to estimate which forces are present between molecules.